And as the boundaries between digital infrastructure and national security blur, Open RAN emerges as a cornerstone of the next generation defense networks. This panel looks ahead to a future where software-defined, AI-optimized radio networks form the foundation for autonomous systems, adaptive battle networks, and resilient communication at the tactical edge. Leaders from the Radisys Corporation and the Department of War's 5G cross-functional team will explore how Open RAN can accelerate a shift from rigid architectures to these dynamic, mission-aware platforms. On this session are Arun Bhikshesvaran. He's Chief Executive Officer of Radisys Corporation. And we also have Andrew Thiessen. He's Chief Technologist of 5G CFT, that at the U.S. Department of War. And gentlemen, welcome.
Thank you very much. Good to be here, Abe and Andrew.
Likewise, look forward to the conversation.
Well, it's great to have you both. Andrew, if you don't mind, I'd like to have you sort of kick off the discussion here today. And the question is this: how do open standardized architectures really align with the Department of War's goals for the modular, secure, and adaptable communications infrastructure?
So, if you've ever heard the 5G cross-functional team talk about the three different lines of effort that we have, one is the use of public networks. The other is doing something that's a little more DoD bespoke, right, which we call line of effort 2 in kind of the hybrid space. But very specifically in line of effort 3, we talk about private 5G or tactical 5G. And I feel like, the concept of open modular architectures really resonates, right, with that third line of effort in the tactical 5G space. Right. Open architecture by definition, right, allow for, a modular, adaptable approach, where you can get multiple vendors involved, where each one of those vendors can play to their particular strengths, right, in the overall market. And of particular importance to DoW is the inclusion of the RAN Intelligent Controller, because this allows DoW to control how the radio access network functions in a way that is very specific, right, to how DoW intends to use it in the field. A lot of the incumbent manufacturers today, when they're designing, their 5G systems, are designing it for best effort internet, right? What I always refer to as just better Netflix. And while that's certainly important in some of the use cases that DoW has, where we're looking at the tactical edge and ultra reliable low latency comms or massive machine type comms, being able to control the RAN, right, very specifically for whatever those particular use cases is critical. And so, the open architecture approach, right, the recent kind of introduction of AI RAN, so we're seeing AI inside the RAN now, I think even kind of further accelerates, what we expect to be quite a bit of value out of the original O-RAN Alliance architecture. And then as we extend that into the real-time space with AI RAN, it's going to provide that much more from a dividend perspective to DoW. From a security perspective, I think, the O-RAN Alliance has already worked really hard to close, some of the opening up of the new reference points, right, in the O-RAN architecture that would have been closed in a proprietary system. That work obviously has to continue. And we can certainly get, further into the discussion, right, later on in the panel.
Yeah, Arun, unless you have a response, I'm going to go on to the next question.
Yeah, let's go.
Yeah. So what role, from your perspective anyway, can commercial Open RAN vendors really play in accelerating this defense modernization and really in the DoW's 5G testbeds and also pilot programs?
Absolutely. That's a great question, Abe. See, the role that commercial Open RAN vendors play is critical to securing the availability of the modular architecture that Andrew talked about. Right. Traditionally, what has happened is everything has been packaged together and everything has to scale independent of whether they are needed or not. When you bring in the modularity, the system becomes much more receptive to the controls that it's getting based on what it's being used for, the use cases, right? So whether it's the CU scaling independently or the DU scaling independently, based on the apps that are being enabled by the RIC, that modularity comes into place. And when you make these modular architectures also cloud native, then you enable auto scaling, right? So all these things are new things that are coming from commercial Open RAN vendors. And what we have done in making sure that people get comfortable with this architecture is two things. Number one, ensuring that we work with a broad cross-section of layer 1 providers. So whether it is an Intel layer 1 or a Qualcomm layer 1 or an NVIDIA Aerial or an HQ or anyone for that matter, right? So you have choices because that gives you the option on which one works best in a particular environment. The second thing that we do is to provide optionality on the compute environment, because you have situations, for example, Andrew talked about the tactical edge, where power and compute footprint is probably going to be constrained in some way, depending on the use case. You might have a backpack based system, for example. So you need that flexibility to be able to run things in a highly compact environment is needed, but at the same time being able to scale and work in an AI RAN mode, for example, where you're sharing the available compute between a RAN workload and an AI workload, right, in a dynamic fashion, and also having that interplay. All this is enabled by the modularity that comes from Open RAN vendors. And what we have done specifically, we have participated in many of the department's efforts over the years to ensure that the maturity of the software is seen, is demonstrated, and gets validated. The NTIA's 5G Challenge is a very good example, where we have participated for a number of years, and we have won numerous awards in there for enabling this end-to-end interoperability. And we are participating, of course, in the Accord program, and all the No for One winners in ensuring that the department's goals are being satisfied with the software that we enable, and then we will continue to do that as well moving forward.
Andrew, anything to add?
Yeah, I mean, a couple of particular dimensions that I think are important, right, is that I think everybody has seen, right, the department really be interested in broadening the defense industrial base beyond the traditional incumbent vendors, right, that are selling into DoW. And again, Open RAN, right, with the modular open architecture allows for, new entrance into that market space rather than having a sole vendor, right, for a 5G G&B. You may have a grouping of vendors, right, again, that may not have ever really participated in Department of War's industrial base. And so I think that's particularly important, right, because we want to get back to a broader industrial base. And then in addition to that, right, I mean, I think participation in a lot of the pilots and test beds that DoW has been doing over the last few years allows for people that aren't used to doing business with the Department of War, maybe an easier entrance point, right, to get used to some of the different requirements that DoW has, whether it's from a performance perspective or cybersecurity, what have you, right? It allows them to get their feet wet, if you will, before trying to scale into solutions for big Army, Navy, and Air Force.
Yeah, and Arun, your last answer is a nice segue into the next question. Really, how does Radisys really approach this interoperability, and what lessons have you learned so far from these real-world multi-vendor Open RAN deployments that really apply to these defense networks in particular?
Yeah, absolutely. So elaborating on what I said earlier in terms of interoperability from a layer one perspective and a compute perspective, but also, as Andrew referenced earlier, opening up the northbound interfaces to the near real-time RIC, and also the O1 interface for orchestration, etc., brings great flexibility into the ecosystem, right? You're now exploring a number of levers that are available that have been hidden in the system for use in a dynamic fashion. So what we have done is, as we have deployed these systems, whether it's a 7.2 based fronthaul or an option 6 based integration, it provides great learning on what system works best in what environment. Right. So a fronthaul based system might not be the most elegant to deploy when you are looking at a dynamically changing landscape, for example, because it brings unpredictability into that fronthaul interface between the DU and the ORU. So you might want a more compact, tightly packaged system there that can be highly mobile and that can survive on its own and not necessarily depend on a whole number of other units to be available. On the other hand, if you're building a large-scale system, right, and you want the scalability to be automatic, you might want to centralize that CU in a cloud environment, and then you have multiple DUs that are distributed, and you might go for a different split there, and the Open F1 would come into play there, and you might even integrate the DU and the RU together to provide that tight connection so that you prevent the latency issues. So these are all lessons that we've learned from the different packaging and the different compute environments, and it allows us to then choose the right solution for the right application, and then of course make it available seamlessly for orchestration and real-time use of applications. So you keep that interface common, and you provide high modularity on everything south from there, and that gives you a very, very different kind of system from traditional 5G deployments.
Mm. Andrew, I want to go into a bit of a security aspect of this topic today, and this certainly is a burgeoning topic, and there's a reason why we have sort of multiple facets to the question. But in this particular case, what are the most pressing security considerations when you adopt Open RAN for these defense applications, and how can they be addressed really from a hardware, software, and also orchestration layer? Andrew.
Yeah, and so like we talked about, the using this open modular architecture exposes reference points that in a proprietary incumbent system typically would have been closed, right? You wouldn't have had access, right? Whether it's, the E2 for the near real-time RIC or the O1 or A1, these interfaces just wouldn't have had an ability for somebody to actually touch those interfaces. And so I think those additional threat surfaces obviously mean that the security needs to be that much more robust, right, to make sure that we're protecting all those new reference points. And there's been a really good concerted effort on the part of the ORAN Alliance to get after that. Additionally, with the softwareization, right, I'm glad I didn't stutter saying that word, right, as we extend software, right, which was the domain of the core, certainly in the 3G, 4G area, and then now with 5G and now AI RAN extending all the way into the G node B, the provenance of the software that's being used, right, becomes particularly important, right? Having a transparent understanding of the software, BOM involved, right, means something because, the DoW certainly wants to make sure that there's no opportunity for malicious or unknown code to make its way into the software systems that DoW is deploying. Hardware, same thing, right? Understanding right down to the component level, what's showing up inside, the solutions that are being sold into DoW matters quite a bit because, pure adversaries are always looking for any entrance point that they can, whether it's now through the ease of software as software extends its reach or the hardware components as well. And so, there's been a lot of effort, right, in DoW. One in particular is that DoW has funded, what we call the 5G Threat Informed Framework, or FIGHT, which is, built on attack, which leverages, credible understanding of threats that are in the wild when it comes to IT systems for attack, and 5G and beyond for FIGHT. And so FIGHT has even been able to address, particulars around Typhoon and Liminal Panda, where we've now seen great power competition and peer adversaries really care and have cared for a while about getting inside of our commercial mobile broadband networks, and anything that exposes the commercial environment then transposes very quickly to the Department of War's environment. And so, making sure we do everything we can to protect the commercial ecosystem means that we're doing that much more to protect the DoW ecosystem as well.
Abe, if I can add something, picking on the word that Andrew used on softwareization, I think it's a beautiful word actually, because what it allows is for the adoption of merchant silicon. So there is no custom ASIC in there. You're looking at merchant silicon and the software that runs on top of that, right? And what we have done is, for example, like with the 5G challenge, we won a special award on software bomb, right? Where we were able to throw open the entire code base and say, look, go do a vulnerability analysis on this one, because that is the level of transparency you need to be able to trust the system. So when you have merchant silicon, you have a software bomb that has been validated, then you have kind of separated these components into things that you can trust in a very clear manner. Because the hardware you can trust, it's merchant silicon. There is nothing in there that is custom. The software has gone through a complete validation, and then you start to modularize it and use all the levers. So I think this is going exactly in the right direction. Personally, for me, I would love a faster pace, but it is moving in the right direction for sure.
Arun, I'm going to stick with you. I wanted to talk about, or ask you to talk about, the integration of AI and edge computing into Open RAN, really helping to enable these use cases like autonomous logistics, intelligence, surveillance, reconnaissance, and even tactical mesh networks. Can you just cover those sort of for us?
Yeah, absolutely. So what we see happening now, Abe, is that you've got this concept of AI that needs to work in multiple levels, right? So inferencing needs to happen at a very local level in certain conditions. For example, when you're out in the battlefield, you cannot always rely on massive engines available everywhere to be able to do it. You might need to do that in a very localized manner. Then you might have the option to elevate to a network edge kind of scenario where you can do other inferencing. And then you can have a central cloud where you do much more sophisticated things as well. And we are now seeing these use cases coming to life where you've got AI happening or operating at multiple levels of the network. And again, when you have open compute environments, it gives you the ability to scale these workloads across all these different activities. So we have had, both for surveillance and intelligence, multiple applications that have been integrated and tested. As you know, we've got a number of partners in the ecosystem, 5G Mill, for example, being one of them, who have integrated this, put it out into the field, made things work. And in the concept of tactical mesh networks, another feature that is very important is integrated access and backhaul, so that you can make things work using the same spectrum, going kind of leading into the shared spectrum scenario as well, for backhaul purposes and for access purposes, and creating a very resilient network there. And what then that allows you to do is to build these mesh networks in a dynamic fashion that can pretty much survive on their own. And one other aspect where it goes beyond RAN, which we have already done as well, is to integrate core networks if needed out in the field as well, right? So that you have the complete stack available for communication. And of course, you can kick back into a higher level environment when available, but we are building these capabilities in a nice, compact compute environment, but at the same time having the ability to scale up and access AI infrastructure that might be available in large data centers, etc.
Mm-hmm. And again, Andrew, if you have nothing to add, I'll move on.
Just one point, right? I think the inclusion of AI in the RAN, like I mentioned earlier, and the move towards, I think, Arun, you talked about it, getting away from bespoke hardware, right? The custom ASICs that we see inside incumbent manufacturer solutions, right, into more general capabilities, obviously the G and GPU. Right. We're seeing, this, again, a big leap in the performance space, going from a non-real-time RIC and a near real-time RIC in the Open Alliance, moving into a real-time space now, accelerated through the use of GPUs and AI having that real-time flexibility on the battlefield to basically modify how the RAN is functioning based on whatever the parameters of the use case are. Critically important to DoW.
And Abe, one more thing is, in AI in RAN, right? We are now industrializing new ways in which the system is learning about what is happening in the field, and even adjusting a scheduler, for example. So traditionally, a scheduler was something that was algorithm driven, right? It doesn't need to be anymore. You are constantly learning and adapting, and the softwareization gives you that capability to do that, where you're not following a certain a logic per se, but you're learning in real time, and you're coming up with new ways to schedule a mix of traffic types that are coming in. So fascinating things that are just being enabled by AI in RAN, and of course using AI on top of RAN as well.
Again, a good segue. Andrew, I want to go with you first on this one, and certainly Arun, chime in when you feel like it. How do you see spectrum sharing, these dynamic network slicing capabilities or private 5G capabilities as well, really evolving in the context of Open RAN for defense and joint force operations as well?
Right. And, I say, I think, wherever possible, I think the department would love to be a fast follower of the scale of commercial industry, right? Creating, new vertical industry ecosystems for 5G, which, we're maybe starting to see the beginning of with industrial automation and some other things. But in order to get after those new industry verticals, you have to have the feature functionality, right? The capabilities built into the 5G system that supports something that's more than just enhanced mobile broadband. And, again, coming back to the RAN Intelligent Controller and some of the stuff that you can do, OUSWRNE had an experiment a number of years ago at Hill Air Force Base where they were doing spectrum sharing between airborne radar systems and 5G and experimenting for the first time with things like PRB blinking. And, that ability to share spectrum, right, between a commercial system and something that's incompatible with it, whether it's airborne radar or something else, those same capabilities, that same toolkit, if you will, can be reused by DoW in those tactical 5G systems for something other than spectrum sharing. So we kind of refer to it as spectrum agility, right? The ability to very, very finely control where energy is put, right, from that 5G system on the battlefield, using all the same techniques that hopefully we see industry pick up, right, for these new industry use cases on the commercial side that we can then get dual use of, out on the DoW side.
Arun.
Absolutely. See, one of the things that we're learning is that when you go out to these environments, the kind of use cases that are present, especially in terms of spectrum sharing, really enables you to deploy these systems in a manner where they are dynamically learning and adjusting. And I think that is a critical thing that we are learning that we probably would not have learned in other, as Andrew mentioned earlier, building large scale networks for people to watch YouTube. That is great. Those are nice macro networks. But what we are talking about here is taking that technology and adapting and creating specialized environments where they have to survive and create tremendous value. So, yeah.
Interesting. So I wanted to round out the discussion with this question. Arun, I'll stay with you, and then we'll have Andrew finish us off here. What should industry and government do, or do more anyway, collaboratively to accelerate this Open RAN innovation while really ensuring supply chain trust, compliance, and this long-term sustainability? How do you reconcile moving at a brisk pace, but also staying true to these other cores?
Actually, it kind of connects back to the earlier question as well in terms of private 5G, right? Because that gives a great, immediate deployment use case where you can start to industrialize things. So we have several customers, I want to say, I can't name them here, who have taken the software that we provide, packaging it with different compute environments, but deploying it in environments where there is shared spectrum and it's a private environment, right? And in these environments, what we are seeing is an amazing pace of innovation. So, for example, in one particular use case, I remember just the system coming up. Our system came up in 24 hours, and an alternate commercial system had been waiting there for months to simply get turned up because it was not really designed for that. Second, once we get this thing going, we have to dynamically learn. So, for example, when we deployed this particular system, we had designed it with a certain coverage environment in mind. And when we started to recognize what else was happening in that environment, that is both inside an environment and slightly outside as well, we were immediately able to adapt the system and make it work in peak performance. Now, a lot of that learnings will eventually get automated and will become an app, for example, that is integrating sensing and communication into one package. So the more deployments we can do, I think that is where we will really accelerate the benefit to the department and to the industry in general.
Yeah, and again, Andrew, accelerating Open RAN, but also staying true to trust, compliance, and also sustainability as well.
Yeah, I mean, I think a big part of it is DoW staying directly in touch with industry, right? And especially the commercial industry side. And so the CFT, right, has been engaging on the industry side for years, right? My tech insertion team, right, has been working religiously, right, to engage with industry. We try to meet industry where industry is. And so I'm sure I'll see you both, right, with the rest of the DoW team and Mobile World Congress Barcelona here in a few months, so that DoW stays on top of all the different commercial innovation, right? So that, again, we're looking at through that lens of that dual use, which is how can then DoW take advantage of something that commercial industry is already kind of peeking into, and then figure out how we can take best advantage of that, again, to leverage the scale. And then getting after secure and trusted vendors, right, certainly is important, adherence to standards, all along the way, whether it's through GPP or the O-RAN Alliance. And then again, I think, there's the DoW is one amongst a set of initiatives inside the U.S. government. It's certainly NTI's Innovation Fund that Arun mentioned earlier has been critical, I think, to helping establish a foothold with a new industrial base around Open RAN, and I think we're seeing that kind of eke into the AI RAN space, and so leveraging the Accord laboratories or the Orchid labs, right? All the innovation, right? The Amanda Toman's team is funded, I think, is particularly important, and there's other parts of the U.S. government that are also working to take advantage of 5G, kind of in addition to or as an extension of what's happening in the commercial space. And so pilots, test beds, right? Experiments, these are the kind of things where it allows for industry to get a first taste of working with the US government and what we'd expect. And I encourage industry to stay on top of that. And certainly we'll be reaching out to industry nonstop to make sure that industry is aware of opportunities.
Yeah.
And Abe, if I can just add one thing on this topic of security and a supply chain that is a trusted supply chain as well. With the modularity and the use of merchant silicon, what you see is that players from the US have a very significant role in how these systems are being realized. So if you look at commercial compute environments, they're all coming from US high-tech companies. If you look at layer one technologies, they are coming from US companies, and that automatically gives you a trusted source that you can work with from a Department of War perspective. And if you add on top of that a software bomb that is also clean and validated, right? That level of transparency that you're getting into the supply chain that is also secure and trusted has been hard to find before. And I think that is a huge benefit that the Open RAN is bringing to this conversation.
Agreed. I really feel like the core of this discussion today, as it should be, is this notion of this shift from the rigid architectures that you both have talked about, really to these dynamic, mission-aware platforms that we're all sort of learning in real time. So certainly a big part of the conversation, and probably that's not going to a lot of runway ahead. Let's put it that way. So we appreciate both of you and giving us your feedback on this topic. Andrew, with the Department of War, we appreciate your time. We know you guys are super busy over there and kind of got a number of spinning plates up in the air, if you will. So we appreciate the time again, Andrew.
Always, right. Happy to participate in these panels. I think, again, it's an example of DOW engaging with industry, and we look forward to future opportunities as well.
And Arun, the Chief Executive Officer of Radisys Corporation, as always, we appreciate your insight. We'll probably see you in just a couple of months in Barcelona, which is where I happen to be at the moment, by the way, on a different thing. But so we appreciate your time, Arun. We'll see you in a couple months.
It's great to be on this panel. And I think these are the kind of conversations that are needed, even in other settings, not just in panels, in the real world discussions as well, to really make things happen and move things forward. So appreciate this opportunity, and like you said, we'll see both of you in a couple of months in Barcelona.
Absolutely. And to all of our viewers out there, thank you once again to our speakers on Operationalizing Open RAN for innovation, interoperability, and mission readiness for U.S. defense networks. For this session on demand, please go to thenetworkmediagroup.com. So long.